Right now, without any effort on your part, a thin liquid film is spreading itself across the surface of your eyes, so smoothly and so continuously that you have no way of feeling it happen. It is happening in the dark, behind your closed eyelids, in a rhythm that started before you were born and will continue tonight, tomorrow, and every day after that, whether or not anything ever makes you feel a single thing. This film is only a few micrometers thick, thinner than a soap bubble, thinner than a strand of spider silk, and yet it is doing something your eyes cannot survive without. It is washing away dust, softening the surface of your cornea, feeding oxygen to cells that have no blood vessels of their own to rely on. And the strange thing, the thing that might surprise you as you lie here settling into sleep, is that this quiet, constant, unglamorous fluid is made of the exact same basic ingredients as the tears that fall when someone receives devastating news, or when a song from decades ago catches them off guard in a grocery store, or when a parent watches their child walk across a stage for the first time. We tend to think of tears as something that begins with sadness, as if the feeling comes first and the water follows, like a cause reaching out and producing its effect. But the water was already there. It was there this morning when you opened your eyes. It was there an hour ago, replenishing itself in a slow and patient cycle, long before any emotion arrived to complicate the picture. This is one of the first small mysteries worth turning over slowly tonight, because it changes the shape of the question we are really asking. The question is not simply why do we cry? The question is why does a system, built for something as unromantic as lubrication and protection, also get called into service when we feel heartbreak, or joy, or overwhelming relief? Why would the body borrow its plumbing for something so different from what that plumbing was seemingly designed to do? Consider, for a moment, what your eyes actually are. They are two small, exposed organs sitting in open sockets, constantly meeting air, dust, wind, and the invisible traffic of tiny particles that drift through every room you have ever stood in. Unlike your lungs, which are tucked deep inside your chest and filtered by nose hair and mucus before air ever reaches them, your eyes sit right out in the open, unprotected except for a fluttering pair of lids and a fluid coating that never lets them dry out. If that fluid stopped even for a few minutes, the surface of your eye would begin to crack, almost like a lake bed in a drought, the smooth curve breaking into tiny fissures that would make focused vision nearly impossible. So evolution, working slowly across many millions of years, arrived at a covering that renews itself constantly in 3 distinct layers, each with its own job. There is an oily outer layer, produced by small glands along the edge of your eyelids, and its purpose is almost embarrassingly simple. It stops the watery part underneath from evaporating too quickly, the same way a thin layer of oil on top of a bowl of soup left out overnight will slow how fast the broth dries up. Beneath that oil sits the watery middle layer, the bulk of what we call tears, produced by a gland tucked up into the side of each eye, just under the bony ridge of your eyebrow. And beneath that watery layer, closest to the eye itself, is a layer made of mucus, which helps the water cling evenly to the surface instead of beating up and rolling away, the way rain beads on a freshly waxed car instead of coating it evenly. 3 layers, 3 separate glandular systems, working together every single second of your life, whether you are awake, asleep, laughing, or grieving. This baseline tear, sometimes called the basal tear, is the one spreading across your eyes right now as you listen. It has no connection to your mood. It does not care whether you are content, or anxious, or simply drifting towards sleep. It is a housekeeping fluid,
something closer in spirit to the fluid that lubricates your joints than to anything we would normally associate with emotion.
And yet, remarkably, the very same lacrimal gland that produces this quiet baseline fluid is also the gland that floods with liquid when grief arrives, or when laughter turns into something closer to crying, or when a wave of unexpected tenderness catches someone off guard while watching two strangers reunite at an airport. The plumbing is shared. The reservoir is the same. What differs is the volume, the speed, and, as we will spend much of this narration exploring slowly, the chemical makeup of what comes out. Here is where the puzzle deepens rather than resolves. If tears already existed for a purely mechanical, protective reason, why did the body ever recruit them for something as abstract as an emotional state? Emotions, after all, live primarily in the brain, in networks of neurons passing signals to one another, in chemicals like cortisol and oxytocin drifting through the bloodstream. None of that, on the surface, seems to have any obvious reason to reach all the way down into a gland sitting above your eye and instruct it to release fluid faster than it can drain away. And yet it does, reliably, across every culture that has ever been studied, in infants only minutes old, and in elderly people who have lived through nearly a century of experience. Something in the architecture of the human nervous system decided, somewhere far back in our evolutionary history, that the eye's plumbing was a useful lever to pull when certain emotional thresholds were crossed. We do not yet have a complete answer for why that particular system, rather than some other bodily response, became the one so tightly bound to sorrow and to joy alike. It is one of those questions where the honest answer, even from researchers who have spent entire careers studying it, is that we understand pieces of the mechanism far better than we understand the reason the mechanism exists at all. What we do know, and what tonight's exploration will slowly unfold, is that not all tears are created equal, even though they all pass through that same small gland above the eye. The tears that keep your eyes moist right now are chemically different from the tears that might fall during a moment of overwhelming sadness, and different again from the tears triggered by a sudden gust of wind or a chopped onion. Researchers who have studied these different tear types under a microscope have found variations in protein content, in hormone levels, in the very structure of what looks, to the naked eye, like simple, identical drops of water. This is a strange thing to sit with as you drift toward sleep tonight, that the substance leaving your eyes in a moment of heartbreak is not simply the same clear liquid dressed up in a sadder context, but something the body appears to be assembling with a slightly different recipe depending on why it was called for in the first place. And so tonight, slowly, without any urgency, we are going to follow this thread from its quietest beginning, the tear that is on your eyes at this very moment, protecting and nourishing without any feeling attached to it at all, toward the more complicated territory of tears that arrive uninvited, tears that seem to erupt from nowhere in the middle of an ordinary afternoon, tears that some people find themselves unable to produce even when they desperately want to, and tears that others find themselves unable to stop. We will move gently through the biology of the glands themselves, through the strange history of how scientists first began asking these questions, and through the layered, sometimes contradictory theories about what emotional tears might actually be doing for us, if they are doing anything at all beyond simply being a byproduct of a nervous system under strain. For now, though, let your eyes stay closed, let that thin, invisible film keep doing its quiet work, and let your mind rest on this one gentle fact. Long before tears ever meant anything, they were already there, keeping watch over something far more basic than a feeling. Let's stay with that quiet, unfelt film for a while longer. because there is far more happening on the surface of your eyes right now than most people ever pause to consider. What sits there, invisible and constant, is not a single layer of water. It is a structure, built in 3 distinct parts, each one resting on the other, like sheets in a bed you never notice being made. The deepest layer, the one closest to the eye itself, is made of mucus. It is produced by small goblet cells scattered across the conjunctiva, that thin, clear tissue lining the inside of the eyelids and the white part of the eye. This mucus layer is sticky in a very particular way. Its job is to help the watery layer above it cling to the surface of the eye at all, because the cornea, that clear dome at the front of the eye, is naturally a little bit water repellent. Without this mucus foundation, tears would simply bead up and roll away, the way water beads on a freshly waxed car, rather than spreading into the even, unbroken sheet that clear vision requires. Above that mucus layer sits the middle layer, the one people usually picture when they think of tears at all. This is the aqueous layer, mostly water, but water carrying dissolved salts, proteins, antibodies, and small amounts of glucose. It is produced primarily by the lacrimal gland, that almond-shaped structure tucked into the bony socket just above and to the outer side of each eye, roughly beneath where your eyebrow arches. This gland is small, perhaps the size of a large almond, and yet it is remarkably active, continuously releasing tiny amounts of fluid throughout every waking hour, whether or not you are aware of it. Anatomists in the 17th century, working with the crude dissection tools of their time, first began mapping these structures in careful detail, and one of the more curious historical figures in this story is a Danish scientist named Niels Stensen, sometimes known by the Latinized name Steno, who in the 1660s identified the duct system that carries tears from the gland onto the eye's surface. Before Stensen's work, the exact source of tears was genuinely unclear to European medicine, with some earlier thinkers proposing that tears originated in the brain itself and simply traveled downward, a theory that sounds strange now, but reflected a reasonable guess given the tools available at the time. Floating on top of this watery middle layer is the outermost layer, a thin film of oil called meibum, produced by small glands embedded along the edges of the eyelids, called the meibomian glands. There are roughly 30 to 40 of these tiny glands lining the upper eyelid, and a similar number along the lower lid, each one opening through a nearly invisible pore right at the lash line. Their oil does something that might seem almost too simple to matter, and yet turns out to be essential. It slows evaporation. Without this oily cap, the watery layer beneath it would evaporate within seconds under normal room conditions, the way a thin puddle disappears quickly on a warm sidewalk. With it, that same layer can last for many seconds longer between blinks, which is exactly the kind of small, unglamorous engineering that keeps an eye comfortable through an entire day of reading, working, driving, watching a screen, without your ever giving it a single conscious thought. This 3-layered structure together is often called the tear film, and under a microscope, in cross-section, it measures only a few micrometers thick, thinner than a sheet of household plastic wrap, thinner in fact than most of what we would consider genuinely thin. And yet within that impossibly slim architecture, mucus, water, and oil manage to stay organized, each layer doing its separate job, coexisting instead of mixing into a single,
undifferentiated smear. This is part of what makes the tear film such an elegant, if underappreciated, biological structure. It behaves less like a simple puddle and more like a tiny, self-maintaining machine, rebuilt fresh with every blink. And blinking, it turns out, is doing more work than most people realize. Each blink is not simply a shutter closing and opening again. It functions as a kind of squeegee, spreading fresh tear fluid evenly across the surface of the eye and pushing older fluid, along with any dust or debris that has settled there, toward the inner corner.
On average, a person blinks somewhere between 12 and 20 times a minute while at rest, though this rate drops noticeably during periods of intense visual concentration, which is part of why eyes tend to feel dry and scratchy after long stretches of reading or staring at a screen. The blink rate has simply slipped, quietly, without permission, and the tear film has not been refreshed as often as it needs. Once tears have done their work, spreading across the eye, they do not simply sit there indefinitely, and they do not only evaporate away. A portion of that fluid drains through a route that surprises many people the first time they learn about it. At the inner corner of each eye, nearest the nose, there are two almost impossibly small openings called puncta, one on the upper lid and one on the lower, each barely visible as tiny dots if you look closely in a mirror. These puncta lead into small canals called canaliculi, which merge into a slightly larger passage called the lacrimal sac, which then drains downward through a duct directly into the nasal cavity. This is why crying, or even just tearing up from a bright light or a yawn, so often produces a runny nose. The two systems are physically connected. Tears are not only wept from the eyes, a significant portion of them are quietly swallowed, in a sense, draining down the back of the throat by way of the nose, dozens of times a day, without a single moment of awareness on the part of the person producing them. All of this constant, wordless activity, the layered film, the blinking, the drainage into the nose, exists for reasons that have nothing to do with sadness. Basal tears, the kind that are on your eyes right now, are working simply to keep the cornea clear, smooth, and functional. The cornea has no blood vessels of its own, which is part of what keeps it transparent enough to let light through cleanly, but that also means it cannot receive oxygen and nutrients the way most other tissues do, through blood flow. Instead, it depends heavily on the tear film sitting on top of it, which carries dissolved oxygen and nutrients directly to the corneal surface. In this sense, basal tears are less like an occasional bath and more like a continuous, quiet life support system, feeding a piece of tissue that has no other way to be fed. Basal tears also carry antimicrobial proteins, among them one called lysozyme, discovered in the early 20th century by the bacteriologist Alexander Fleming, years before his more famous discovery of penicillin. Fleming noticed, somewhat by accident, that his own nasal mucus and tears seemed to dissolve certain bacterial cultures in his laboratory dishes, and further investigation revealed that tears contain an enzyme capable of breaking down the outer walls of many bacteria. This means that every time you blink, you are not simply moistening your eyes, you are also bathing them, continuously, in a mild but genuinely effective antiseptic, one your body manufactures without instruction,
without effort, and without your ever noticing the smallest hint of relief that this protection provides. The eye, exposed as it is to open air, dust, pollen, and the endless traffic of microorganisms that drift through any ordinary room, would be extraordinarily vulnerable without this quiet chemical defense running in the background at all times. It is worth pausing here, in the dim, drifting quiet of listening to all this, to consider how strange it is that a system this active, this chemically sophisticated, this constantly renewing itself, produces no sensation at all when it is working correctly. You do not feel your lacrimal gland releasing fluid. You do not feel the oil layer forming its thin cap, or the mucus layer anchoring everything in place, or the tears sliding, unnoticed, down through those two small openings near your nose and into the back of your throat. The entire system is engineered, it seems, to disappear from conscious awareness precisely when it is succeeding, announcing itself only through discomfort when something goes wrong, when the oil layer thins, when the aqueous layer runs short, when blinking slows too much during a long day of screen time, and the eyes begin, for the first time all day, to ask quietly for attention. This raises a natural question, one we will sit with gently as we continue drifting through this subject tonight. If the ordinary tears, keeping your eyes comfortable right now, are silent, chemical, and entirely without feeling, what changes, physically, inside these same glands and ducts, when a tear finally does carry an emotion along with it?
Let's stay with that question for a while, but before we can answer it properly, we need to understand that there are actually three quite different kinds of tears sharing the same small plumbing, and it helps, in a sleepy sort of way, to think of them as three separate departments working out of the same modest office. The first department, the one we have been discussing, produces what scientists call basal tears. These are the tears that are present right now, on your eyes, whether you are aware of them or not, whether you are lying in bed with your eyes closed or reading in bright afternoon light. Basal tears are the baseline, the background hum of ocular maintenance, and they are produced continuously at a slow, steady rate that requires no trigger at all. They exist simply because the eye exists, and because a cornea, that clear dome at the front of the eye, has no blood vessels of its own, and depends entirely on this thin film of fluid to receive oxygen and nutrients from the surrounding air. Basal tears are, in a sense, the least dramatic tears of all, and yet they are the ones doing the most relentless work, hour after hour, day after day, for an entire lifetime, without ever once being noticed by the person whose eyes they are quietly keeping alive. The second department is more excitable. These are reflex tears, and they exist for a completely different purpose than basal tears, even though they emerge from the very same glands. Reflex tears are an emergency response, a kind of flushing mechanism the eye deploys the moment it detects something it interprets as a threat. Cut an onion, and within moments, your eyes begin to sting, and then to water, sometimes quite suddenly. What is happening there is worth slowing down to appreciate. When the cells of an onion are ruptured by a knife, they release an enzyme that reacts with sulfur compounds already present in the onion's tissue, and together, these form a new, unstable compound, a volatile gas that drifts upward into the air around the cutting board. This gas reaches the surface of your eyes, where it reacts with the thin layer of moisture already sitting there, and that reaction produces a mild sulfuric compound, an actual, if very dilute, irritant,
right there, on the surface of your eye. Your cornea, which is one of the most densely innervated tissues in the entire human body, notices this immediately. Nerve endings, particularly ones called free nerve endings that lie almost at the surface, react to that chemical irritation and send an urgent signal along a nerve, called the trigeminal nerve, up into the brainstem and back out again to the lacrimal glands with a simple, unambiguous instruction: flood the area and flush it clean. This is why cutting onions produces tears so much faster and so much more abundantly than basal tear production ever could on its own. It is not sadness, and it is not even truly comparable to sadness, though the tears look identical to the untrained eye rolling down someone's cheek in a kitchen. It is a defensive reflex, evolved not for onions specifically, since onions have only been cultivated for a few thousand years, a blink of time in evolutionary terms, but for any airborne irritant the eye might encounter. Smoke behaves the same way. Sit near a campfire, and the moment the wind shifts and a curl of smoke drifts toward your face, your eyes will begin to water within seconds, often before you have even consciously registered the smell. Fine particles of ash and unburned carbon settle on the eye's surface and irritate those same corneal nerve endings, and the same reflex arc fires. The same instruction travels down to the same glands, and the same flushing response begins, all without a single thought passing through your mind. Gust behaves similarly, as does a sudden gust of wind on a dry day, which is why cyclists and motorcyclists so often find their eyes streaming, even on days that have nothing sad about them at all. Bright light produces something closely related, though the mechanism branches off in an interesting direction. Step outside on a clear day, after being indoors for a while, and some people find their eyes watering, sometimes accompanied by a sneeze, a strange and largely harmless pairing, known informally as the photic sneeze reflex, though scientists are still not entirely certain why the two are connected in some people and not in others. One working idea involves a kind of neural crosstalk, a signal meant for the visual system spilling over slightly into the trigeminal nerve pathway that also governs tearing and sneezing, though this remains an area of ongoing study rather than settled fact, and it is worth resisting the temptation, even in the pleasant fog of near sleep, to treat an interesting hypothesis as a proven mechanism. Yawning brings its own small mystery into this picture. Almost everyone has noticed that a deep, full yawn can bring tears to the eyes, even when nothing sad or irritating is happening at all. This appears to be mostly mechanical. The muscles around the eyes and the jaw are closely connected by shared tissue and shared nerve pathways, and the sheer physical effort of a wide yawn, the way it compresses the face, tightens the muscles around the eye socket, and puts pressure on the lacrimal gland itself, seems to be enough to squeeze a small amount of tear fluid out, rather the way pressing gently on a wet sponge will send a few drops running out from between your fingers even if you never intended to squeeze it. This is closer, in its underlying cause, to basal tear release than to true reflex tearing, since no irritant is involved, only pressure and proximity. Then there is simple mechanical irritation, which shares real overlap with the reflex category but deserves its own moment of attention, because it happens so often, and so unremarkably. An eyelash falling loose and drifting sideways across the surface of the eye. A contact lens sitting slightly off-center. A small speck of grit carried in on the wind. In every one of these cases, the cornea's nerve endings detect direct physical contact rather than a chemical irritant, but the resulting signal travels the same trigeminal pathway, triggers the same urgent message to the lacrimal glands, and produces the same rapid flushing response, because from the nervous system's point of view, the goal is identical either way. Get whatever this is off the surface of the eye, and do it quickly, using the fastest and most reliable tool available, which happens to be a sudden surge of fluid. What becomes clear, turning all of this over slowly, is that basal and reflex tears, despite looking the same and using the same glands, the same ducts, and much of the same chemical machinery, are answering two entirely different questions. Basal tears are always asking, quietly and continuously, how do we keep this surface healthy right now, in this ordinary moment? Reflex tears are asking, urgently and briefly, how do we get rid of this threat immediately? The third department, the one responsible for emotional tears, asks a question that is stranger still, one that has nothing to do with the physical surface of the eye at all, and we will turn our attention toward it shortly. But first, it is worth explaining something that almost everyone has experienced and almost no one has thought carefully about, which is why any of these tears, whether from onions, from smoke, from a hard yawn, or from something that has nothing to do with the eyes at all, so reliably leave the nose running along with them. The explanation lies in that same small drainage system mentioned earlier, the pair of tiny openings near the inner corner of each eye, so small that most people have never noticed them despite them being there their entire lives. Under ordinary basal conditions, tears drain through these openings, down through a thin canal, and into the nasal cavity at a slow, unremarkable trickle, one that the nose absorbs and manages without any sensation at all. But when tear production suddenly increases, whether from a chopped onion, or from a wave of feeling that has nothing to do with vegetables, the volume of fluid arriving at those two small drainage openings can exceed what the nasal passages can quietly absorb. The excess has nowhere reasonable to go, except downward and outward, mixing with the mucus already present in the nose, and the result is the familiar, faintly embarrassing experience of a runny nose arriving in close company with watering eyes, two symptoms that feel unrelated but are, in fact, plumbed directly into the same overwhelmed system.
Let's follow the actual path a feeling takes as it becomes a tear, because it is a longer and stranger journey than most people imagine, one that runs through nearly every major structure of the nervous system before it ever reaches the eye. Start with the cornea itself, that clear dome at the front of the eye, because even in the case of emotional tears, the eye does not act alone. The cornea is one of the most densely innervated surfaces in the entire body, more sensitive, weight for weight, than the tip of a finger or the surface of the tongue. This sensitivity comes from a nerve called the trigeminal, the same nerve responsible for sensation across most of the face, and it explains why the eye reacts so quickly and so decisively to almost anything that touches it. But the trigeminal nerve is not simply a wire carrying information outward from the eye. It is also, in a sense, part of the return path, because many of the signals involved in tear production, including some tied to emotional states, travel along branches connected to this same trigeminal system on their way back down to the lacrimal gland. The eye, in other words, is wired into a nerve that touches the whole face, which is part of why crying rarely stays contained to the eyes alone. From there, the relevant signals descend into the brainstem, that dense, ancient stalk of neural tissue at the base of the brain, the part responsible for functions so fundamental that most animals with a spine have some version of it. The brainstem does not care about sonnets, or grief, or nostalgia. It cares about breathing, swallowing, heart rate, and the basic regulation of the body's internal weather. And yet it is here, in this old and unglamorous structure, that many of the physical mechanics of crying are coordinated. A cluster of neurons within the brainstem, sometimes referred to loosely as the lacrimal nucleus, acts something like a small relay station, receiving instructions from higher up in the brain and translating them into the specific outgoing signals that reach the tear glands, the blood vessels of the face, and the muscles around the eyes and throat. Picture a switchboard operator in an old telephone exchange, someone who does not originate any of the messages passing through, but without whom none of them could reach their destination. The instructions that reach this brainstem relay, when someone is crying from emotion, rather than from smoke or dust, come from much higher in the brain, from structures involved in evaluating meaning, memory, and significance, rather than raw physical sensation. This is where the limbic system enters the story, a loosely connected group of structures, including the amygdala and parts of the hypothalamus, often described, a little too simply, as the brain's emotional core. The amygdala is particularly important here. It is often associated with fear, but its actual job is broader than that. It functions more like an alarm and evaluation center, constantly scanning incoming experience for anything that carries emotional weight, whether that weight is frightening, moving, overwhelming, or unexpectedly tender. When the amygdala registers something as significant enough, it does not simply produce a private internal feeling and leave it there. It sends signals outward, downward, into the very physical systems that prepare the body to respond, including, eventually, the tear glands. The hypothalamus, sitting just beneath the thalamus near the center of the brain, plays a slightly different but closely related role. It functions as a kind of central regulator for the body's internal state, a structure with a long evolutionary history of managing hunger, temperature, hormonal rhythms, and the balance between rest and alertness. When emotional signals from the amygdala and nearby regions reach the hypothalamus, it helps translate that emotional information into the kind of bodily instructions the autonomic nervous system can act on. This is one reason crying so rarely arrives as an isolated event involving only the eyes. It tends to arrive as a small weather system moving through the entire body at once. The autonomic nervous system deserves a slow, careful mention here, because it is the part of the nervous system responsible for everything a person does not consciously direct: the heartbeat that continues without instruction, the digestion that proceeds in the background, the sweat glands that respond to heat before a person notices they are warm. It has two main branches, often described as opposites, though in practice, they act more like two hands working the same instrument. The sympathetic branch prepares the body for action, quickening the heart, tightening certain muscles, sharpening alertness. The parasympathetic branch does something closer to the opposite, slowing the heart, easing muscles, encouraging the body toward rest and recovery. Tear production, including the emotional variety, is governed largely by this parasympathetic branch, the same branch responsible for the pleasant heaviness after a good meal, or the slow settling of the body after a long day. This is part of why crying, despite feeling overwhelming in the moment, is so often followed by a kind of physical quiet, a loosening in the chest and shoulders that people sometimes describe, with more accuracy than they may realize, as feeling wrung out. But an emotional response rarely stays confined to a single system, and this is where breathing enters the picture. The same brainstem structures involved in coordinating tears sit close to the structures that regulate breathing rhythm, and the two systems appear to influence one another during a crying episode. Breathing during crying often becomes shallower and more irregular, sometimes catching in the throat, sometimes arriving in short involuntary bursts that most languages have their own word for.
whether it is called sobbing in English, or by any of the similarly onomatopoeic terms found across other languages, words that seem to have been built, across many unrelated cultures, to imitate the very sound they describe. This is not incidental noise. The muscles of the diaphragm and chest wall, along with the muscles surrounding the voice box, are being recruited by the same broad neural event that is also instructing the tear glands, which is why a person crying from deep emotion often finds their voice affected before they even notice their eyes have started to water, a slight tightness or waver arriving first, as though the throat had been informed before the eyes. The face itself becomes an active participant as well, not merely a stage where tears happen to appear. Small muscles around the eyes tend to tighten during crying, along with muscles around the mouth and brow, producing the particular facial configuration that people across very different cultures recognize almost instantly as the look of someone crying, even in a photograph with no sound and no context. Researchers going back to the 19th century, including Charles Darwin in his work on the expression of emotion, noted how consistent this facial pattern appeared to be across different populations, though the deeper explanation for why these particular muscles are recruited in this particular pattern remains an area where full agreement has not been reached. What does seem clear is that this facial activity is not a side effect layered on top of tear production. It is being organized by many of the same neural signals, arriving at the muscles of the face at roughly the same moment they arrive at the lacrimal glands, which is part of why crying so rarely looks like tears alone, and almost always looks like an entire face rearranging itself around a feeling. Taken together, this means that by the time a single emotional tear reaches the outer edge of the eye, an entire relay of activity has already taken place across a surprising portion of the nervous system, from evaluation in the limbic regions, through coordination in the hypothalamus and brainstem, out along parasympathetic pathways to the tear glands, and outward again to the breath, the voice, and the small muscles of the face, all arriving together with a kind of orchestrated timing that no single structure could produce alone.
It raises an obvious question, one that has occupied scientists for longer than most people would guess, which is why the body would bother building such an elaborate, resource-intensive, multi-system response just to produce a small amount of salty water on the surface of the eyes. And it is to that question, the question of what emotional tears might actually be for, that we can now slowly turn. Before turning to function, it's worth sitting for a while with just how strange emotional crying looks when you place it next to almost anything else an animal does. Most behaviors that persist across a species have an obvious shape to them. A reflex protects tissue. A grimace warns off a rival. A cry of pain in an infant summons a caregiver quickly and predictably. Emotional tears do not fit into these categories nearly as cleanly, and that is part of why they have puzzled naturalists, physicians, and philosophers for so long. Water appears on the surface of open eyes, in public, often at moments when a person would probably prefer it not to happen, triggered not by any injury to the eye itself, but by something happening entirely inside the mind. There is no dust in the air. There is no onion nearby. The trigger is a thought, a memory, a piece of music, the sight of someone else's face, and somehow that internal event reaches all the way out to the surface of the eyes and produces something visible to anyone standing close enough to notice. What makes this even more striking is how specific it is to us. Plenty of animals produce tears in the basic mechanical sense. A dog's eyes will water if the wind is sharp enough, or if something irritates the surface of the eye, and the same basic drainage and lubrication system exists across many species with eyes similar to ours. Elephants have been observed with fluid running from their eyes during moments that certainly look distressing to a human observer, and there has been considerable public fascination with such moments over the years. But observing fluid is not the same as establishing that the fluid was produced by an emotional state rather than by physical irritation, changes in blinking, or purely reflexive causes. And researchers who study this carefully have generally been cautious about drawing a straight line from a wet eye to an inner feeling in a non-human animal. The honest position, even now, is that humans remain the only species for which there is strong, repeatable evidence of tears produced specifically by emotional experience, without any accompanying physical irritant, on a regular and predictable basis throughout life. That is not a small distinction. It suggests that whatever emotional tears are doing, they are doing it in a way that either does not exist elsewhere in the animal kingdom, or exists in such a different, more subtle form that it has not yet been clearly demonstrated. This uniqueness invites an evolutionary question that does not have a tidy answer yet, although it certainly is not for lack of trying. One of the oldest and most intuitive explanations treats crying as primarily a signal, a way of broadcasting a person's internal state to the people around them without needing to say a single word. There is something appealing about this idea, and something almost visibly true about it, since tears are hard to miss and hard to fake convincingly, which may be exactly the point. A face with tears on it looks different from a face without them, even under poor lighting, even at a distance, even to a small child too young to understand the situation causing them. If tears function partly as an honest signal of internal distress, one that is difficult to produce convincingly on command, then they might help other people know, quickly and reliably, that something is genuinely wrong, prompting comfort, protection, or a change in how they treat the person crying. There is some support for this in how people respond to images of a crying face compared to the same face without tears, since studies using this kind of paired comparison have found that the presence of visible tears tends to shift how the face is perceived by others, often toward greater sympathy or a sense that support is needed, even when the rest of the expression is held constant. It is a modest, careful finding, not a sweeping one, but it lines up with the signaling idea in a reasonably direct way. At the same time, plenty of crying happens with nobody else in the room at all. People cry alone in cars, alone in bathrooms with the door locked, alone in bed at 3 a.m, with the lights off and no one anywhere near enough to see. If tears exist purely to signal something to an audience, this private crying becomes harder to explain, since an audience is precisely what is missing. Some researchers have proposed that solitary crying might still carry a kind of signaling function, just delayed or displaced, since a person who has been crying often looks different afterward, with red eyes, a different tone of voice, a certain rawness that others notice even hours later. Others take a different approach entirely, and argue that at least part of what tears do has nothing to do with communication and everything to do with something happening internally, inside the person crying, regardless of who else happens to be present. This is sometimes framed as an emotional regulation idea, the notion that the physical act of crying, the change in breathing, the flush of activity through the parasympathetic nervous system might help shift a person's internal state, nudging a nervous system that has become highly activated back toward something calmer, in something like the way a long exhale can take the edge off a moment of panic.
It is worth being honest about how uneven the evidence for this calming effect actually is. Some studies asking people to recall how they felt before and after crying have found that people often report feeling better afterward, sometimes describing a sense of release or lightness once the crying has passed. But other studies, including ones that measured physiological markers like heart rate, rather than relying only on self-report, have found much less consistency, with some instances of crying leaving a person's body more activated rather than less, at least in the minutes immediately following. Context seems to matter enormously here, more than early theories accounted for. Whether another person was present and how they responded, whether the crying happened at the end of the distressing episode or in the middle of it, whether the person felt some sense of resolution afterward, all of these seem to shape whether crying left someone feeling better, worse, or simply the same, just now visibly tired. This is one of those areas of the science where the honest answer is genuinely mixed rather than quietly settled, and where drawing too firm a conclusion in either direction would be getting ahead of what the research actually shows. There have also been attempts to explain crying through its chemistry, and these are worth mentioning slowly, because they tend to circulate in a simplified form that goes further than the evidence supports. In the 1980s, the biochemist William Frey ran studies comparing the composition of emotional tears to tears produced by irritation, such as those triggered by chopping onions, and reported some differences in protein content between the two types, along with the presence of certain stress-related hormones in emotional tears that appeared less prominent in irritant tears. This research is frequently summarized in a kind of shorthand that has traveled very widely as proof that crying flushes stress hormones out of the body, offering a tidy chemical explanation for why people so often say they feel better afterward. But the original findings were narrower and more provisional than that popular summary suggests. The sample sizes involved were small, and the idea that the small volume of fluid released during typical crying meaningfully changes the concentration of these substances circulating in the bloodstream has not held up well under closer scrutiny. The chemistry of tears is real and worth studying, but it has not, so far, delivered a single clean mechanism that explains why crying happens or what it accomplishes once it does. What all of this adds up to, laid out slowly and without rushing toward a conclusion, is a picture of a behavior that very likely serves more than one purpose at once, and possibly different purposes in different situations for the same person. Crying in front of a trusted friend after a difficult conversation may be doing something quite different, biologically and socially, from crying alone in the dark over a memory that surfaced unbidden.
The signaling account and the regulation account are not actually opposed to each other, and most researchers working in this area today tend to hold both possibilities loosely rather than insisting on one to the exclusion of the other. No brain scan has located a single tear center that flips on like a switch. No blood test has isolated a single stress compound that crying reliably removes. What research keeps finding instead is a distributed, layered system built from pathways that also handle breathing, facial movement, memory, and social bonding, repurposed together in a way that produces something recognizable across nearly every human culture, even though its underlying purpose remains only partly mapped. It is worth sitting with that unresolved quality for a moment longer, because it sets the stage for a related and equally human puzzle, the puzzle of why some people cry so easily at the smallest provocation, while others seem to hold entirely still through circumstances that would undo almost anyone else. Before getting to that puzzle of why some people cry easily and others don't, It helps to spend some time on a stranger question, one that people notice in their own lives but rarely stop to examine closely. Why does the same wet warmth around the eyes show up at a funeral and at a wedding? Why does it show up when a runner crosses a finish line after years of training, and also when that same runner stubs a toe hard enough to see stars? Why does a piece of orchestral music, with no plot and no characters, and nothing sad happening in it at all, sometimes produce tears just as reliably as bad news does? If crying were simply the body's way of marking sadness, none of this would make sense. But crying does not track sadness. It tracks something else, something that sadness, pain, grief, frustration, anger, relief, awe, beauty, music, reunion, laughter, and even ordinary happiness all seem to brush up against from completely different directions. Picture, for a moment, a narrow mountain pass that many different roads happen to converge on, roads that start in entirely different valleys and were built for entirely different purposes: a trade route, a pilgrimage path, a shepherd's track, a road built by an army centuries ago for moving supplies. None of these roads has anything to do with the others where they begin, but geography being what it is, they all funnel through the same gap in the rock, because that gap happens to be the only low point in an otherwise unbroken ridge. Tears seem to work something like that pass. The emotional roads that lead to them start in very different places, but they converge on a shared low point in the nervous system's landscape, a point that gets reached whenever internal arousal rises sharply and the ordinary machinery of regulation is, even briefly, outpaced. Start with sadness, since it is the most obvious entry, and the one most people assume is the whole story. Sadness, at least in its everyday form, tends to build gradually. A disappointing outcome, a loss that has been expected for some time, a quiet ache that settles in over an evening. This kind of sadness sometimes produces tears and sometimes does not, and researchers have long noticed that the sadness which reliably brings tears is usually the sadness that carries a strong sense of helplessness alongside it, a sense that nothing more can be done, that the outcome is now fixed. The sadness without that helplessness, sadness that still has an obvious next step attached to it, is less likely to end in tears than the kind that has run out of road. Physical pain works on a related but distinct circuit. A sudden sharp pain, the kind that comes from a slammed finger or a twisted ankle, can produce tears almost instantly, well before any conscious thought about the injury has had time to form. This is closer to a reflex than an emotional response, tied to the same rapid signaling that makes a person gasp or flinch. But pain that is anticipated, pain that a person has braced for and is enduring on purpose, such as pain during a medical procedure someone has consented to, produces tears far less reliably, because bracing itself is a form of regulation, and regulation tends to hold the pass closed, even when the arousal underneath it is considerable. Grief sits nearby, but is not identical to sadness, and people who have lived through it often describe this difference clearly, even if they have never had a word for it. Grief tends to arrive in waves rather than as a steady state, and the tears associated with it often follow the same wave pattern, appearing suddenly in response to a small trigger, a scent, a piece of clothing, a turn of phrase, and then receding just as suddenly. What seems to matter here is less the size of the loss and more the size of the gap between what the mind expected to encounter, based on years of learned prediction, and what it actually encountered in that moment. A parent's coffee mug sitting in a cupboard is a small, mundane object, but the nervous system, on seeing it, briefly predicts the parent's continued presence out of sheer habit, and the collision between that automatic prediction and the reality can be sharper than a more abstract, sustained thought about the loss itself. Frustration and anger are less often discussed alongside crying, but many adults recognize them as an uncomfortable and sometimes embarrassing source of tears. Uncomfortable, partly because frustration tears can arrive in situations, such as workplace disagreements, where a person very much does not want to cry and may worry it will be misread as weakness, rather than as what it usually is, which is a nervous system that has been pushed past a threshold of controlled effort. Frustration often builds through repeated attempts that keep failing despite real effort, and anger often builds through a sense of being blocked or wronged with no immediate way to correct it. Both states involve high physiological arousal, and both can end at the same narrow pass as sadness does, even though the emotional content driving them is nothing like sadness at all. Relief offers a particularly clean illustration of the shape of this whole system, because relief tears typically arrive only after a threat has fully passed, not while it is still active. A person waiting for medical test results or waiting to hear whether a loved one survived an accident is often composed, sometimes eerily so, throughout the waiting itself. It is frequently only once the good news arrives, once the danger is confirmed to be over, that tears appear, sometimes to the person's own surprise. This timing makes more sense once arousal is understood as the common ingredient. The waiting period involves sustained tension, but tension held in a state of active vigilance, which keeps regulatory systems engaged and the pass closed. The moment vigilance is no longer needed, that engagement can drop away quickly, and the sudden release itself becomes its own kind of surge. Awe and beauty are stranger cases still, because there is no threat, no loss, and often no personal stake involved at all. A person standing at the rim of a large canyon for the first time, or hearing a piece of music built with particular harmonic tension and release, can find tears rising with no identifiable cause beyond the scale or the pattern of what they are perceiving. Researchers who study awe describe it as arising when something exceeds a person's existing mental frameworks, when the mind is briefly asked to accommodate something larger or more intricate than its usual categories comfortably hold. Music seems to work on a closely related mechanism, particularly music that sets up a clear expectation and then either delays or subverts it in a way the listener finds satisfying rather than merely surprising. That combination of expectation and release maps quite well onto the same arousal then drop pattern seen in relief, which may be part of why sad songs and triumphant songs can both produce tears through structurally similar musical devices. Reunion draws together several of these threads at once: joy, relief, and the collapse of anticipation, all arriving in the same instant, which is likely why reunions, whether at airport arrivals gates or after long separations of other kinds, are among the most reliable tear-producing situations across nearly every culture that has been studied. And then there is laughter, which under ordinary conditions produces nothing more than amusement, but which, past a certain intensity and duration, can tip into tears through what appears to be sheer overload of the same respiratory and facial systems that crying itself relies on, the two responses sharing enough physical machinery that one can slide into the other almost by mechanical necessity. Even plain happiness, uncomplicated by relief or reunion,
can sometimes cross this threshold, as anyone who has cried while watching a child accomplish something they worked hard for already knows. Laid side by side like this, these 11 or so very different experiences start to look less like separate categories, each with its own private trigger for tears, and more like different paths up the same mountain, each shaped by its own terrain, but each eventually reaching a shared elevation at which the ordinary business of staying composed briefly gives way. What still needs explaining, though, is why that elevation sits so differently from one person to the next, why the same piece of music or the same small disappointment can send one person quietly reaching for a tissue while leaving another person entirely dry-eyed, and whether that difference says anything meaningful about temperament, upbringing, or simply the particular day each of them happens to be having.
Let's set that question aside for a moment, because before we can ask why people differ in their threshold for tears, it helps to know what tears actually are, physically, chemically, sitting there on the skin or caught in a tissue. And this is a place where popular explanation has run well ahead of what the evidence actually supports, so it's worth slowing down here, the way you might slow down walking into a room you've heard described many times but never actually entered yourself. You have probably encountered the claim, likely more than once, that emotional tears are the body's way of flushing out stress hormones, that crying is essentially a chemical release valve, and that this is why people so often report feeling better afterward. It is a satisfying idea. It has the shape of good science, cause and effect, substance and mechanism, and it gets repeated in articles and casual conversation with a confidence that outpaces what the underlying research can actually bear. So let's look at what is more carefully established and where the uncertainty genuinely lives. Tears, whatever their source, are mostly water, which is unsurprising but worth stating plainly, since everything else present is dissolved or suspended in that water in comparatively small amounts. Alongside the water there are salts, primarily sodium and chloride and potassium, the same general family of electrolytes you would find in sweat or in blood plasma, though not in identical proportions. This is part of why tears taste salty, and why old sailors and old poets alike have reached for the ocean as a metaphor for weeping. There are also proteins, quite a few of them, some of which have antimicrobial properties, helping to protect the surface of the eye from infection, and some of which are enzymes involved in maintaining the health of the cornea. There are lipids too, oily compounds that form a thin film across the surface of the tear layer, which helps slow evaporation and keeps the eye from drying out between blinks. And there are smaller molecules present in trace amounts, including some that have drawn particular scientific attention, among them a stress-associated hormone and a natural opioid-like compound, both of which have been detected in emotional tears in at least one influential study from the 1980s. That study is worth pausing on, not to dismiss it, but to understand what it actually showed and what it did not. The researcher, a biochemist named William Frey, collected tears from volunteers under two different conditions. Once, while they were chopping onions, which produces what is called a reflex tear, and once, while they were crying in response to an emotionally moving film, which produces what we've been calling an emotional tear. When he compared the two samples, he found that the emotional tears contained higher concentrations of certain proteins than the reflex tears did. This finding, published decades ago now, is very often the sole evidentiary thread from which the entire toxin-flushing story gets woven, repeated so many times across health articles and casual retellings that it has taken on the weight of settled fact, Even though the original study involved a fairly small number of participants and has not been extensively replicated at the scale that would let scientists speak about it with real confidence. This matters for a simple reason, one that applies far beyond the subject of tears. A single study, however well designed, however intriguing its results, is a beginning, not a conclusion. Science tends to build confidence gradually, through many hands and many attempts, researchers in different labs approaching the same question from different angles, sometimes replicating a finding, sometimes complicating it, sometimes failing to reproduce it at all, and thereby revealing that the original result may have been specific to those particular conditions, rather than a stable and general truth. Emotional tear composition is still, even now, an area where the sample sizes in existing studies are often small, where collection methods vary from lab to lab, and where the picture that has actually been confirmed is considerably less tidy than the popular version suggests. Consider, for instance, just how differently tears might be collected. Some studies gather tears by touching a small strip of filter paper to the lower eyelid, essentially wicking away whatever fluid gathers there. Others collect larger pooled samples using tiny glass capillary tubes. Some ask participants to cry while watching a sad film in a laboratory setting, which is itself a strange emotional context, being asked to feel something real while sitting in a chair wired up for observation. Others rely on people crying in more natural, less controlled circumstances, which is harder to standardize, but arguably more authentic. Each of these choices can influence what ends up in the sample, how concentrated it is, how much reflex tearing gets mixed in with emotional tearing, even the time of day the tears were collected, since hormone levels in the body shift across a 24-hour cycle, the way tides shift across a shoreline. All of this means that comparing results across different studies is a bit like comparing photographs taken with different cameras, in different light, at different times of day, of what might not even be quite the same subject. There is also the question of what elevated levels of a substance in tears actually means for the body as a whole. Tears are produced by small glands, and the total volume involved in ordinary crying is modest, a few grams of fluid at most in a typical episode. Even if certain stress-related molecules are present at higher concentrations in emotional tears than in tears produced by cutting an onion, the total quantity of that substance being removed from the body through this particular pathway is almost certainly too small to meaningfully lower stress hormone levels circulating in the bloodstream. To put it in a more everyday image, it would be a little like trying to cool down a swimming pool by removing a single cup of warm water from it. The proportion is simply too small for the mechanism to work the way the popular explanation implies, even if the underlying observation about tear composition turns out to hold up. None of this means crying does nothing for how a person feels afterward, and it would be a mistake to swing too far in the other direction and conclude that the relief so many people report is purely imaginary or unrelated to the physical act itself. It's just that the explanation for that relief likely lies elsewhere, perhaps in the extended exhale that so often accompanies crying, which shifts the balance of the nervous system in a calming direction, the way a long breath out at the end of a stressful task can. Perhaps it lies in the social response. Crying often invites comfort, physical closeness, the attention of someone who cares, all of which have their own well-documented calming effects, entirely independent of what is dissolved in the tears themselves. Perhaps it lies simply in the passage of time, since strong emotional states rarely last as long as they feel like they will in the moment, and crying often coincides with, rather than causes, the natural ebbing of that intensity.
Untangling which of these plays the largest role, and how much they interact with each other, remains genuinely open territory. The kind of question current research is still circling, rather than having settled. It's worth sitting with this uncertainty, rather than rushing past it, because there is something valuable in learning to recognize when a widely repeated explanation has outrun its evidence. Crying is not the body performing a kind of internal laundry, flushing away toxins, the way a filter clears sediment from water. It is something more entangled than that, involving the nervous system, the respiratory system, the social environment a person finds themselves in, and quite possibly, the mechanics of tear fluid itself, all interacting in ways researchers are still working to map. The chemistry is real, and genuinely interesting, but it is one thread among several, not the single explanatory string that ties the whole experience together. What tears are made of, then, turns out to be a smaller and more modest story than the one so often told about them. Water and salt and protein, and a scattering of trace molecules whose significance is still being worked out. And that modesty, rather than being a disappointment, opens up a different and perhaps more interesting question, which is what crying actually does, moment to moment, inside the body of the person doing it, quite apart from whatever happens to be floating in the tears themselves.
A newborn's first cry has no tears in it at all. This surprises a lot of people, because in nearly every film and photograph, a crying baby is shown with a wet, glistening face. But in the first weeks of life, the eyes usually stay dry no matter how hard the baby is wailing. What's happening instead is almost entirely acoustic. The sound itself, that sharp, rhythmic, rising and falling cry, is the signal, carrying all the information before any liquid enters the picture. Newborns are, in a sense, broadcasting rather than weeping, and the broadcast is remarkably well engineered. Researchers who've studied infant cries have found that the pitch, rhythm, and urgency of a baby's cry can shift depending on what's wrong. Hunger, sounding subtly different from pain, pain different again from simple overstimulation, though the differences are often too fine for an untrained ear or even an exhausted new parent's ear to reliably sort out. What matters most in those early weeks isn't the precision of the message, but the fact that it cannot be ignored. A newborn's cry sits in a frequency range that the human ear finds almost impossible to tune out, which is not an accident of biology so much as the product of it. A species whose infants could be easily ignored would not have survived very long. The tears come later, usually somewhere between 2 and 6 weeks after birth, though the exact timing varies quite a bit from baby to baby. This isn't because babies grow more upset with age, but because the tear ducts themselves are still finishing their development, small tubes and glands maturing on their own private schedule, somewhat separate from the emotional and vocal machinery that was already fully online at birth. It's a strange thought, if you sit with it, that crying and tears are not really one system switching on at once, but two different systems that happen to arrive at different times and then spend the rest of a person's life closely, though not perfectly, overlapping. Once tears do enter the picture, something else begins to change, more slowly and less visibly than the arrival of the tears themselves. In early infancy, crying is almost entirely involuntary, a reflex response to discomfort, hunger, cold, an overfull diaper, a sudden loud noise, with essentially no capacity yet for the baby to modulate or delay it. There's no strategy in it, no waiting for a better moment, no sense of an audience. It's closer to a car alarm than a conversation. But somewhere across the first year, and then increasingly through the second and third years of life, crying starts to become entangled with something new, the growing awareness that another person is present, watching, responding. Developmental researchers sometimes describe this as the crying becoming more social, meaning it starts to serve not just as a signal of internal state, but as a kind of address directed at a particular person, shaped in small ways by whether that person is in the room. Anyone who has spent time around toddlers has likely witnessed this shift firsthand, even without naming it. A child who falls and scrapes a knee while a parent is watching may cry loudly and dramatically. The same child, taking a similar tumble alone in a backyard with no one nearby, might glance around, register that no one saw, and get up in near silence. This isn't manipulation in any calculated sense, and it would be a mistake to read it that way. It's closer to the toddler's nervous system learning, through repeated experience, that crying in the presence of a caregiver reliably brings comfort, closeness, and relief, while crying into an empty room brings nothing but the sound of one's own voice. The body is doing what bodies do, adjusting its behavior based on what tends to work. This is also roughly the period in which self-soothing begins to take shape, though calling it a single skill undersells how many small pieces are involved. A very young infant has almost no capacity to calm itself once distress takes hold. The crying simply continues until an outside source, a parent's arms, a breast or bottle, a rocking motion, brings it down. Over months and years, children slowly begin building an internal toolkit, thumb-sucking, humming, clutching a familiar blanket, repeating a soothing phrase a caregiver has modeled for them. None of this happens on a fixed timetable. Some children develop these tools earlier, some later, and the pace has more to do with temperament and environment than with anything resembling intelligence or maturity in a simple sense. A child who cries easily at 4 is not behind a child who cries rarely at the same age. They are simply built, for the moment, along a different curve. Attachment theorists, watching this unfold across decades of careful observation, have argued that the way a caregiver responds to a child's crying, consistently, warmly, promptly, or unpredictably, becomes woven into the child's expectations about comfort itself. A child whose cries reliably bring a response learns, at a level well beneath conscious thought, that distress is something that gets met, that the world contains people who show up. This doesn't mean a child who cries less has been loved less. The relationship between attachment style and the sheer frequency of crying is far messier than that, shaped by dozens of other threads including simple physiology. But it does suggest that crying, even in its earliest and most reflexive form, is already doing double duty, expressing an internal state while simultaneously testing and reinforcing a relationship. Empathy adds another layer to the picture, and it arrives on its own, gradual schedule as well. Very young children, oddly, sometimes cry in direct response to another child's crying nearby, a kind of contagious distress that researchers have observed even in infants only a few months old, well before anything like a mature understanding of another person's inner life could plausibly be in place. This early form isn't quite empathy in the fuller sense. It seems to function more like an unfiltered emotional echo, one nervous system picking up the alarm of another, without yet separating self from other. True empathic crying, the kind that responds specifically to someone else's grief or pain, with an understanding that it belongs to them, and not to oneself, tends to develop later,
deepening across childhood, as the capacity to hold another person's perspective as genuinely separate from one's own comes online.
By adulthood, this capacity for empathic tears is remarkably variable from person to person, some adults finding themselves moved to tears by a stranger's grief on the news, others feeling the sadness just as strongly, but experiencing it without any tears at all. Which brings us to a question that seems to surface in nearly every conversation about crying sooner or later. Why do some people cry so easily? At films, at songs, at the sight of someone else's kindness, while others rarely cry even during periods of real hardship. It's tempting to reach for a simple story here, to say the easy criers are more in touch with their feelings, or that the rare criers are somehow guarded or repressed, but the research doesn't support such a tidy division. Differences in crying frequency are shaped by a tangle of factors, including temperament present from early childhood, cultural norms about when and where crying is acceptable, hormonal differences that shift somewhat across the lifespan, and simply the accumulated pattern of what a person's environment has rewarded or discouraged over many years. None of this maps cleanly onto emotional depth. A person who cries rarely may feel things just as intensely as a person who cries often. The difference often lies not in the size of the feeling, but in how directly it travels to the tear ducts, a pathway shaped by biology and history in equal measure. As adulthood gives way to later life, crying tends to shift once more, though the shift is subtler and less studied than the dramatic changes of infancy and early childhood. Some older adults report crying more easily than they did in midlife, moved by things that once might have passed without much notice, a piece of music, a memory, a small act of generosity from a stranger. Others report the opposite, a kind of hard-won steadiness that comes with having weathered a great deal already. Physiological changes play some role here too, since tear production and the composition of tear film both shift with age, occasionally making the eyes drier overall even as emotional responsiveness, by many accounts, seems if anything to soften and open rather than close down. It's a reminder that the story of crying across a life isn't a straight line from reflexive to controlled to something else entirely, but more like a long looping path, one that keeps circling back to the same basic question every human eye has been asking since that first unmusical cry in the delivery room: is someone there, and will they come? Which brings us to something worth sitting with quietly for a while. Crying almost never happens in a vacuum, and even when it does, some part of the mind seems to be imagining who might see it. Tears are strange this way. They are, biologically, a private event, a matter of glands and ducts, and the particular chemistry of a particular feeling. But they are also, and maybe primarily, a signal, something built to be read by another set of eyes. It's worth slowing down on that word, signal, because it carries a lot of weight. A signal is different from a symptom. A fever is a symptom. It happens whether anyone is watching or not, and it doesn't change depending on who walks into the room. Tears are more complicated than that. There's real evidence that people cry differently depending on whether they believe they're alone, and that the presence of another person, even an imagined one, can shape how a cry unfolds. Think about what happens when you watch someone cry. Not a stranger on a screen, but someone close to you, someone whose face you know well enough to read its smallest changes. There's a particular software the human brain seems to run in that moment, a fast, mostly unconscious calculation. Is this person in danger? Do they need me to move toward them or give them space? Did I do something? The eyes go glassy and swell slightly. The light catches differently on wet skin than on dry skin, and somewhere in the ancient wiring of the observer's brain, a small alarm quietly sounds, not fire alarm loud, but present, insistent, like a phone buzzing in another room. Researchers who study this have found that photographs of faces with tears added digitally, tears that weren't there in the original image, are reliably rated as sadder and more in need of help than the identical photographs without them. The tears themselves seem to do a great deal of the communicative work, almost independent of everything else happening on the face. There's something almost architectural about how visible tears are built. Human eyes sit in shallow sockets, unshadowed by heavy brow ridges, the way some other primates' eyes are, and the skin around them is thin and richly supplied with blood vessels, which is part of why the area flushes and swells so readily. Some researchers have proposed, though this remains genuinely debated rather than settled, that the human eye evolved to be an unusually effective transmitter of emotional information, the sclera, the white part surrounding the iris, being far more visible in humans than in most other primates, whose eyes tend to be more uniformly dark and harder to read from a distance. If that idea holds up, and reasonable scientists disagree about how much weight to put on it, then tears might be operating on a stage that was already built for visibility, adding a glinting, moving signal to a display surface evolution had already made unusually legible. Whether or not that specific story is correct in all its details, the basic pattern holds without dispute. Wet eyes are more noticeable, at greater distance and in worse light, than dry ones. That noticeability seems to matter. But noticing tears is only the first step, and here is where things get genuinely complicated, because the same wet eyes can produce wildly different reactions depending on almost everything else happening around them. Picture a child crying because a tower of blocks fell over. Depending on the room, that same event might bring a parent rushing over with soft words, or might earn a brief, patient wait for the storm to pass, or in some households, a sharper response meant to hurry the crying along toward being finished. None of these responses are about the tears themselves changing. The tears are doing the same job, chemically and physiologically in each case. What changes is the meaning assigned to them by the people around the crier, and that meaning is shaped by things far outside the moment itself, by how tired the parent is, by what that particular family believes crying is for, by what that culture, that decade, that household has decided tears mean. This is where the idea of display rules becomes useful, a term researchers use to describe the mostly unspoken agreements a culture holds about when an emotion may be shown and when it should be managed, softened, or hidden. Display rules aren't laws, and nobody sits a child down to recite them formally, but children absorb them early and thoroughly, the way they absorb the rhythms of their native language before they could ever explain a grammar rule. In some settings, tears at a funeral are expected, even required, a visible sign of the depth of a loss, and their absence might be read as coldness or a failure of feeling. In other settings, particularly historically in parts of Northern Europe and among certain professional classes in Britain and the United States, composure at a funeral was itself the expected performance, tears held carefully in check, grief expressed through the straightness of a spine rather than the wetness of a cheek. Neither of these is more natural than the other. Both are learned, both feel, to the people raised inside them, like simply how a person behaves, which is precisely what makes display rules so powerful and so easy to mistake for instinct. Gender adds another layer to this,
And it's worth being careful here, because the patterns that show up in research are statistical tendencies within cultures, not universal laws about what any individual man or woman feels or does. Across many, though not all, societies studied, women report crying more frequently than men, and the gap tends to open up specifically around puberty, before which boys and girls cry at fairly similar rates. That timing is suggestive. It points less toward some late-blooming biological switch, and more toward a period in life when social expectations about emotional display sharpen considerably, when boys in many cultures begin receiving more direct and indirect messages that tears are something to manage, minimize or hide, while girls often receive more permission, sometimes even more expectation, to let tears show. Testosterone itself may play some role, since it has been proposed to have a mild suppressing effect on the physical crying response, though the size and even the existence of that particular effect remains contested among researchers, and it's nowhere near large enough on its own to explain the full pattern seen across cultures.
What's easy to lose in a conversation about gender and crying is how much variation exists inside each group. How many men cry often and openly, how many women were raised in households or professions where tears were as carefully guarded as they were for anyone. The population-level pattern is real, but it sits like a faint tide line on a beach that's mostly shaped by countless individual, local, particular currents, family temperament, professional culture, the specific losses and joys of a specific life. A soldier from a culture with strict rules about masculine composure might weep without embarrassment at the birth of a child, in a context where that particular tear has been culturally carved out as acceptable, even celebrated, while remaining stone-faced through hardships that would bring someone else to tears in an instant. The rules are rarely simple bans. They're maps, intricate ones, marking certain occasions as safe harbors for tears, and others as open water, where crying carries real social risk. The setting matters just as much as the culture and the gender of the person crying. A private cry, alone in a car with the radio off, or in the shower, where the sound of water offers a strange, useful cover, serves a different function than a cry that happens in front of another person. Alone, crying can simply run its course, can be regulatory in the most literal sense, letting a nervous system that's been running hot slowly settle back down without an audience to manage or perform for. In front of someone else, crying becomes, whether the crier intends it or not, a kind of communication, and it tends to invite one of two broad responses. Sometimes it draws people closer, prompting comfort, a hand on the shoulder, a softened voice, the sense of being tended to. Other times, and this is the part people often find confusing, and even a little painful to think about, tears create discomfort in the observer, rather than care, an awkward shifting of weight, an urge to change the subject, sometimes even a flicker of irritation that seems to arrive from nowhere. Understanding why the same tears can land so differently, drawing one person nearer while pushing another away, means looking closely at what's actually happening inside the observer's own mind in that moment. And that's worth turning to next. For now, let's set the observer aside for a moment and ask a simpler, older question. One that people have probably been asking each other in one form or another since long before anyone thought to study it in a laboratory. Does crying actually make a person feel better? It seems like it should be a straightforward thing to test, and yet it turns out to be one of the more slippery questions in this whole area, because the honest answer, the one that actually holds up against the evidence, is that it depends, and it depends on more variables than most people would guess, sitting alone in the dark trying to puzzle it out. Start with what happens in the body during the cry itself, because this part is measurable and fairly consistent. Heart rate tends to climb in the minute or so before tears start. Breathing gets faster and more irregular. The whole system revs up the way it might before a sudden physical effort. Then, as the crying continues, something interesting happens. If the cry is allowed to run its full course, uninterrupted, in a setting that feels safe enough to let go, heart rate and breathing often settle below where they started. Not always, not for everyone, but often enough that researchers studying autonomic nervous system activity during crying have documented this pattern again and again, a kind of overshoot and return, the body swinging up into activation and then swinging back down past its starting point into something calmer than before. It's a little like the way a struck bell rings loud and then quiet, the sound fading not into silence exactly, but into a stillness that feels different from the stillness before the bell was struck. That immediate physiological settling is real, and it's tempting to stop the story there, to say crying is simply a release valve, a way of letting pressure out of a system that had built up too much of it, and afterward the pressure is gone and the person feels lighter. Plenty of people describe exactly this experience. But when researchers began asking people not just how they felt in the minutes right after crying, but how they felt an hour later or the next morning, the picture got considerably more complicated. Some people report the classic relief, a sense of having released something, a loosening in the chest, a mind that feels less crowded. Others report feeling worse, not better, drained and a little raw, as if the crying opened something up without actually resolving it, leaving them more tender rather than less. Both of these are common enough that neither can be dismissed as an outlier or a misunderstanding of one's own experience. One of the clearer patterns to emerge from this research has to do with timing, in particular, the gap between the immediate aftermath of crying and what comes later. Right after a cry, many people do report short-term relief, that settling the body just went through translating into a subjective sense of calm. But researchers who have followed people over longer stretches, asking how they felt, not just minutes but hours, after an episode of crying, have found that this initial relief doesn't always last, and sometimes it reverses entirely. A person might feel better immediately, and then, an hour later, feel just as bad as before, or occasionally worse, the sadness or frustration that prompted the tears still fully present and now joined by a kind of fatigue, the particular tiredness that comes from having cried hard. This matters because it means that studies asking about crying's benefits at different time points can arrive at strikingly different conclusions, not because the researchers disagree about how to measure things, but because crying's effects genuinely change shape as time passes, the way a scent can smell one way when it's fresh, and another way entirely an hour later. Exhaustion deserves its own moment of attention here, because it's easy to overlook. Crying, especially hard, sustained crying, is physically effortful. It engages muscles around the eyes and throat and diaphragm that don't usually get that kind of workout. It involves real cardiovascular activation, and it often coincides with a night of poor sleep or a day already worn thin by whatever caused the tears in the first place. Some of what people describe afterward as feeling worse may not be about the crying itself failing to help, but simply about being tired, the ordinary tiredness of having used up a lot of energy on something intense, layered on top of whatever emotional weather brought the tears on to begin with. It's worth holding these apart, even though they arrive tangled together, because a person exhausted after crying might assume the tears did nothing useful, when really, the tears did their work, and the tiredness is just the bill that came due afterward, separate from the transaction itself. Then there's the question of who else was there, and what they did, which turns out to matter enormously, possibly more than any other single factor researchers have identified. Crying in the presence of someone who responds with warmth, who leans in rather than away, who offers comfort without rushing to fix things or minimize them, tends to be associated with better outcomes than crying alone, and considerably better outcomes than crying in front of someone who responds with irritation, awkwardness, or the kind of hurried reassurance that really just wants the crying to stop. This is sometimes called the social support hypothesis, and it helps explain why studies asking simply whether crying helps, without asking anything about the surrounding circumstances, tend to get such a muddled range of answers. The tears aren't the whole story. The room the tears happened in is part of the story too. Who was in it, what they said, what their face did, whether the crier felt safe enough to let the whole thing unfold, or felt watched and judged and hurried toward composure. This is also where something called co-rumination becomes relevant, a term researchers use for a particular pattern that can show up in close relationships, especially among friends. Co-rumination happens when two people, talking about something upsetting, end up going over it again and again together, dwelling on the problem, replaying it from different angles, without moving toward any resolution or new understanding. It can feel, in the moment, deeply bonding, two people leaning into shared distress, and there's real comfort in not being alone with a difficult feeling. But some research on this pattern suggests that extended co-rumination, particularly when it involves crying together over the same unresolved hurt repeatedly, can actually deepen sadness or anxiety over time, rather than easing it, the conversation functioning less like a release and more like a groove, worn steadily deeper into a record, the needle finding the same scratch again and again. This doesn't mean sharing difficult feelings with another person is unwise. It means there seems to be a difference between processing something with someone, moving through it toward some kind of new footing, and simply revisiting it together without much forward motion. And crying can accompany either pattern, which is part of why its effects are so hard to pin down from the outside. Shame complicates this picture further, and it operates in a way that's almost the opposite of comfort, working against relief rather than toward it. A person who cries and then feels embarrassed about having cried, who worries they were too much, too emotional, too visible in a moment when they'd rather have stayed composed, often reports feeling worse afterward, not because the crying itself failed to do its physiological work, but because the shame layered on top of it created a second problem that the tears never had any power to solve in the first place. In this sense, the culture and setting discussed a little earlier don't just shape whether someone feels comfortable crying, they shape what happens after the tears stop, whether the person is left with a nervous system that's settled and a mind that feels a little clearer, or a nervous system that's settled and a mind now busy managing embarrassment, replaying the moment, wondering who saw and what they thought. The tears did their part either way,
what happened next determined how the whole experience got remembered and felt. Finally, there's the reason for crying itself, which turns out to shape the outcome as much as any of these other factors. Crying about a loss that can't be undone, grief for someone who has died, tends to follow a different emotional arc than crying out of frustration over something that still might be fixed, which follows yet another arc than crying that arrives seemingly out of nowhere, unmoored from any single clear cause, the kind that leaves a person more puzzled than comforted once it passes. Researchers who've tried to compare crying's effects across these different situations have found that lumping them all together, treating every instance of tears as the same event with the same expected outcome, obscures more than it reveals. It's a little like asking whether exercise is good for the body without specifying whether someone means a gentle walk or an all-out sprint. The general category holds many different experiences inside it, each with its own shape and its own likely aftermath, and it's really only by looking closely at the particulars, who, why, where, and what happened next, that any honest answer begins to take form.
If we drift back now, away from the particulars of any one modern cry, and let the mind wander instead through centuries, a curious pattern appears. People have always cried, and people have always tried to explain why, and almost every explanation they arrived at tells you more about the age that produced it than about the tears themselves. It's a bit like watching how a single object, say a candle flame, gets described differently by a physicist, a poet, and a priest. The flame doesn't change. The vocabulary reaching toward it does. The earliest serious attempt to explain tears in something like medical language comes from ancient Greece, and it rests on an idea that feels almost charming now in its wrongness, though it was taken with total seriousness for well over 1,000 years. This was the theory of the four humors, the notion that the body contained four essential fluids: blood, phlegm, black bile, and yellow bile, and that health was a matter of these fluids staying in proper balance. Emotion, in this framework, wasn't something happening in an organ called a brain, quietly firing electrical signals. Emotion was fluid dynamics. Grief was understood as a kind of excess, a overflow, and tears were the visible spillage of an internal system that had tipped out of balance. Hippocrates, and later Galen, whose writings would shape Western medicine for well over a millennium, wrote about the brain itself as a kind of gland, cool and moist, whose job included regulating these fluids, and weeping was sometimes described as the brain releasing a surplus of moisture down through unseen channels into the eyes, almost the way a full sponge releases water when squeezed. It sounds strange to modern ears, but notice what it got right by accident. Tears really do involve fluid moving through a real anatomical pathway, and the sensation of pressure and release that accompanies a good cry isn't entirely a metaphor. The humoral theory reached for the wrong mechanism, but it wasn't reaching in a random direction. Alongside this physical theory, and often layered right on top of it without much sense of contradiction, ran centuries of religious and literary meaning, which treated tears not as plumbing, but as language, a communication between the weeper and something larger than the self. In many religious traditions, tears appear as evidence of sincerity, proof that a prayer or a confession wasn't merely spoken, but felt all the way through the body. Medieval Christian mysticism developed an entire vocabulary around what was called the gift of tears, a state in which weeping during prayer
was considered a sign of grace, something to be sought rather than avoided, and certain monks and nuns wrote of tears as a kind of second baptism, a cleansing that happened again and again over a lifetime rather than once. In classical literature, tears carried a different but related weight. Homer's warriors weep openly, without shame, weep on the battlefield, and weep in front of their comrades, because in that world, crying wasn't a sign of weakness so much as a sign of the depth of what a person had lost or loved, the emotional equivalent of a scar earned honestly. It's worth sitting with how differently that reads, next to some of the modern discomfort described earlier. The person hiding tears in a bathroom stall, worried about seeming unprofessional. The tears haven't changed in 3,000 years. The meaning wrapped around them has traveled a long and winding road. For a very long stretch of history, nobody looked closely at tears themselves, at their physical substance, because the tools to do so simply didn't exist, and because the questions people were asking were philosophical and spiritual rather than chemical. That began to shift slowly with the rise of anatomical study in the Renaissance, when physicians started actually dissecting the human body with careful attention rather than relying on inherited texts. It was during this period that the lacrimal gland, the small almond-shaped structure tucked above the outer corner of each eye, responsible for producing the watery part of tears, started to be mapped and understood as a distinct piece of anatomy rather than a vague channel from the brain.
The Danish anatomist Niels Stensen, working in the late 1600s, is often credited with clarifying that tears come from this gland and drain through small openings near the inner corner of the eye into the nose, which is also, incidentally, why a good cry so often comes paired with a runny nose. The fluid has somewhere real to go, and the nose is right there waiting for it. This was a genuine turning point, because it moved tears out of the realm of theoretical body fluids and into the realm of observable, dissectable, describable structure. You could finally point to the thing and say, "Here, this is where it comes from. This is where it goes." The microscope, once it became a serious scientific instrument in the 17th and 18th centuries, opened the fluid itself to a kind of inspection nobody had previously imagined possible. Early microscopists were fascinated by everything: blood, saliva, pond water, and eventually tears, and what they found was that tears were not simple water at all, but something layered, something with structure invisible to the naked eye. This microscopic curiosity laid a very slow foundation for a question that wouldn't be seriously investigated for another 200 years or more, which is whether tears produced by emotion might actually differ, chemically, from tears produced by a poke in the eye or a sliced onion. Nobody in the 1700s had the tools to answer that, but the question had at least become askable, in a way it simply hadn't been before, back when tears were mostly a matter of theology and balance. It was Charles Darwin, in the 1870s, who brought something like modern scientific method to the specific question of emotional tears, and it's worth pausing on how strange his contribution actually was, because Darwin approached crying not as a philosopher or a poet, but as a naturalist cataloging behavior across species, the same careful, patient observational style he'd brought to finches and barnacles. In his book on the expression of emotions in man and animals, Darwin gathered reports from missionaries, doctors, and travelers around the world, asking a simple but oddly difficult question: do people everywhere cry from emotion? And do infants cry with tears from birth? And if not, when do the tears begin? What he found complicated things
rather than settling them. Newborns, he noted, cry vigorously, but often without producing visible tears for the first several weeks of life, the tear ducts still maturing, which suggested that whatever crying accomplishes for an infant in those early days, it isn't accomplished through the tears themselves, but through the vocal distress call alone. Darwin also puzzled, somewhat famously, over why humans weep at all when other animals in visible distress generally don't, at least not with the streaming tears humans produce. He floated an explanation involving the muscles around the eyes, the idea that intense muscular contraction during screaming or crying might mechanically compress the tear glands and squeeze out fluid, almost as an incidental side effect, a kind of biological accident rather than a designed function. It's an idea modern researchers regard with real skepticism now, since it doesn't easily explain quiet, tearful crying without any accompanying grimace or vocal distress. But Darwin deserves credit for treating the question as genuinely open, worth actual evidence, rather than assuming the answer was obvious. For roughly a century after Darwin, the study of crying dropped mostly out of serious scientific attention, treated as too soft, too subjective, too hard to measure in a laboratory, and it wasn't really until the 1980s that anything resembling modern tear chemistry got underway in earnest. This is where the biochemist William Frey enters the story, doing work that's still cited constantly today, sometimes with more confidence than the original findings can really support. Frey and his colleagues collected tears from volunteers under two very different conditions. Once while they cut into onions, producing what are called reflex tears, and once while they watched deliberately chosen sad films, producing what are called emotional tears, and then compared the chemical makeup of the two samples in the laboratory. They reported differences in protein concentration between the two types, emotional tears appearing to carry a higher protein load, and this finding rippled outward into popular science writing as the origin of an idea many people now take as settled fact, the notion that emotional crying literally flushes stress hormones and toxins out of the body in a way that reflex crying from a cut onion simply cannot. It's a compelling story, tidy and satisfying, the kind that fits neatly into a single sentence and travels well. But the actual science here is far less settled than the popular version suggests, and this is really where the modern puzzle begins, the one that current researchers with far more sophisticated tools than Frey had available are still turning over, unable to close the case cleanly, one way or the other.
Let it settle now, all of it, gently, the way sediment settles in a glass of water left overnight on a nightstand. Nobody has ever proven that a good cry removes cortisol from your bloodstream in any meaningful way. The protein differences Frey found were real, but proteins in tears could reflect all sorts of things: arousal, blood flow, even how long someone had been crying before the sample was collected, not necessarily some purging of emotional toxins. Later researchers, trying to replicate and extend that work with larger samples and better instruments, have found the picture messier than the tidy version suggests. Some studies find a small drop in stress markers after crying. Some find no change at all. Some find that how a person feels afterward depends less on the tears themselves and more on where they were, who was near them, whether they felt safe enough to let go in the first place. So if you've heard, somewhere along the way, that crying is your body's built-in detox system, hold that thought loosely. It might be partly true. It might be mostly folklore dressed up in laboratory language. Nobody knows for certain yet, and anyone who tells you otherwise with complete confidence is probably simplifying more than the evidence allows. What does seem to hold up, across many different kinds of studies, is something a little less dramatic but maybe more interesting. Crying appears to be less about expelling some harmful substance and more about signaling, both outward to other people and inward to your own nervous system, that something has shifted, that a threshold has been crossed, that you need something you didn't have a moment before. Think of it less like a drain unclogging and more like a bell ringing. The bell itself doesn't fix anything, but it tells the house that something needs attention. And this brings us, gently, back to where this whole long unwinding of a story began, hours ago now if you've been listening since the start, with something as small and unremarkable as the tear film sitting invisibly across the surface of your eyes right now, whether they're open or closed. That thin, triple-layered coating, oil on the outside, water in the middle, mucus on the inside, has been doing its quiet work the entire time you've been listening to this, blinking every few seconds without your permission or attention, keeping the surface of your eyes from drying out, from clouding, from catching every speck of dust that drifts through a bedroom at night, from clouding. That baseline tearing never asked for your gratitude and rarely got it. It's the most boring kind of crying there is, if you can even call it crying, and it is also, in its own way, the foundation everything else in this story stands on. Without that ordinary, unglamorous moisture, none of the more dramatic tears, the reflex tears from onions and smoke and wind, the emotional tears from grief and joy and overwhelm, would have anywhere to happen. The eye has to already be wet for it to weep. From there, the story moved to protection, the reflex arc that makes your eyes flood, without asking your permission, the instant something sharp or acrid touches the surface. Sulfur compounds from a sliced onion, smoke from a fire, a fleck of dust caught in the wind. That kind of tearing is old, evolutionarily speaking, shared in some form across many animals that have eyes at all, a straightforward defense mechanism, no thought required, no emotion necessary, just nerve endings, doing their appointed job, the way a smoke detector does its appointed job, indifferent to whether the smoke came from a burning house or a piece of toast left too long in the toaster. Then the story climbed upward, out of pure reflex and into something stranger, the tears that come with feeling rather than injury. And here is where the science gets genuinely uncertain, in the good way, the way that means there's still real thinking left to do. Why does sadness produce tears at all? Why does joy sometimes produce the exact same physical response, the same prickling behind the eyes, the same tightening in the throat, even though joy and sadness feel like opposites from the inside? One idea, still debated, suggests that tears appear specifically at moments of emotional overflow, when a feeling becomes too large or too sudden for the usual channels of expression to handle, regardless of whether that feeling is painful or wonderful. A wedding, a reunion at an airport, the birth of a child, a long note held perfectly in a piece of music, all of these can produce tears not because something is wrong, but because something is, briefly, more than the nervous system knows quite how to hold. That idea has intuitive appeal, and it fits a lot of everyday experience, but it hasn't been proven in any tidy, final way. It remains a hypothesis, a good one, but still open. The story also passed through memory along the way, through the strange way old grief can resurface decades later at unexpected moments, triggered by a smell, a song, a stranger's gesture that echoes someone long gone. That, too, connects back to the eyes and the emotional centers of the brain, sitting close together, in ways researchers are still mapping, still refining,
still arguing gently over in journals most people will never read. And it passed through communication, through the idea that visible tears might function as an honest signal to the people around us, harder to fake convincingly than words are, which is one reason a crying face tends to soften people, tends to draw others closer rather than pushing them away, at least in most circumstances, most cultures, most relationships. Though even that isn't universal, context matters enormously. A grown man crying in one setting might be met with comfort, and in another, historically at least, with discomfort or judgment. And that difference has less to do with biology than with the layered, shifting expectations every culture builds up over generations about who is allowed to show what, and when, and in front of whom.
Because that's the other thread running underneath all of this. Quietly. The whole time. Culture shapes crying every bit as much as biochemistry does. Some societies have historically treated tears, especially from men, as a private matter, something to be managed and mostly kept behind closed doors. Others have built entire public rituals around collective weeping, professional mourners in some historical traditions whose job was literally to cry loudly and visibly at funerals. Their tears, a form of honoring the dead that everyone present understood and expected. Neither approach is more natural than the other. Both are human. Both are learned, absorbed from childhood onward, from watching what happens when other people around you cry and what doesn't happen, and slowly building a private sense of when it's allowed. And underneath all of that cultural variation, underneath the debated evolutionary stories and the incomplete chemistry and the genuinely unanswered questions still sitting on researchers' desks tonight, there is simply this. Crying, in nearly all its forms, tends to bring some kind of relief, eventually, even if science can't yet fully explain why or how. Not always immediately. Sometimes a cry leaves a person feeling worse for a while, raw, tired, a little embarrassed. But often, given enough time and enough safety, something does settle afterward. The breathing slows, the shoulders drop. Whatever was too large to hold a few minutes earlier becomes, somehow, slightly more carryable. If you're still here, this deep into the night, your own eyes have almost certainly not cried once through any of this. They've just been doing what they always do, that patient, invisible blinking, spreading that quiet tear film back and forth, keeping everything clear and unclouded without asking for any credit. Notice that, if you can, without trying to change it. Notice the slow rise and fall of your breath, however it's moving right now. There's nothing left to figure out tonight. The onions are put away. The old griefs can rest where they are. The chemistry will still be there tomorrow, unresolved and patient, waiting for someone else's careful hands to keep testing it. For now, just the blinking, just the breath, just the quiet dark. Rest well.